So, can people hear me? Yeah? So what I'll talk about today is how the web is the sensor to the humanity. So let's think about the web, right? What do we have on the web today? We have a large number of online computing applications, right? So everything from blogs, social media, social networks, various kind of communication applications, and so on. And the question is, what do these things have in common? Right? So what these things have in common is that they allow us for rich and dynamic interactions between the people and the content that people both create and consume. So the difference is that traditionally the web was thought of as a static library where we basically go and just browse it. Today, the web is really where we interact with each other. And if this is the place where we interact, what more is there? Another important thing is that this is large scale. So what this means is that it's being used by billions of people all over the world. And the interesting thing is that when we are using the web, what's happening is that basically everything we do on the web leaves a digital trace, right? So basically the usage patterns, interaction patterns, content creation patterns are logged, or they leave some digital trace that can be studied, okay? So in a sense, what we can think about the web today is that this is basically our laboratory for understanding humanity. Basically, it allows us to capture and see things that have been going on for millennia, but we never were able to see them. Now we can actually see them at a very fine granularity. So if you think about this, right, what this means is basically that generally, right, the science advances when invisible becomes visible. And this is exactly the case what's happening here, right? Things that were around us from forever were very hard for us to measure and observe. Now we get a very good trace and almost like a telescope, a sensor into all these things. So, right, what is the question? The question is, how can we understand the fundamental patterns of human behavior from these raw digital traces, right? Can we do that? And what I will do in my talk, I'll show you some examples of how we can do that. So in order for us to do that, the first thing we need to kind of take this data and come up with a unified data representation. And it turns out that these digital traces of activity, the way you can think about them is you can think about them through the lens of the networks, right? So the idea is that I can take this data and represent them as graphs, static, dynamic, weighted, unweighted, directed, undirected, where the nodes can be people, can be web documents, can be blog posts, and then there are interactions between these objects or entities. So this can mean communication, can mean friendship, can mean a hyperlink, things like that. Okay? So now that we have a common kind of data representation and we have these large networks, we can start analyzing them. What's interesting is that analyzing large graphs by itself opens a bunch of very interesting technical challenges, both in terms of developing theory for understanding networks, both in terms of the computer science theory and also the graph theory, in terms of algorithms, how do we compute over these massive wiring diagrams or networks, and not even how do we compute in terms of the algorithms and what kind of data mining techniques we need, but also in terms how do we scale up across the machines or even over one single large memory machine, right? Assuming that we are able to do these technical things, which kind of as engineers and computer scientists we do, the question is what kind of interesting things can we learn? So what I'll show you now is kind of two examples where we can learn something about human behavior and not only learn, but also influence it. So the first question I'd like to tell you something about is this process that every one of us has experienced, right? Is how do we become a member of a community? We change a job, we go to a new school, there is some community of people, we'd like to fit into that community. How does that process take place? How do we become members of those communities? So the idea is the following, right? So if I want to understand this process, I want to have a way to measure it. And one way to measure it is to look at the language of the community. So the idea is that language builds the collective identity. So if I can measure how the language of the community and how the language of an individual change over time and how they relate to each other, I can basically get a window into this process of how people become members of the communities. Okay, so we will look at the language that is being used in online communities. So now, what is interesting that there, if we go back to the linguistics literature, there is a number of kind of funny hypotheses about how the language changes. So for example, it has been argued that innovation in language comes from adolescent women. So basically women between ages of 16 to 19 are innovators in language. Why is that? It's not clear, right? It could be kind of that this is biologically critical period. It could be a teenage rebellion, things like that. Similarly, it's been observed or hypothesized that the stability, basically the freezing of your language, of your vocabulary, happens for older adult speakers. And the question is, again, why? Right? Is this biological? Is basically our brain getting more and more frail so we can't learn new words? Or is it something else? Or maybe, emotionally, adults are more stable, so they say, no, I won't take on this jargon, thank you. Right? So those are kind of the questions. So now, how would I go and obtain a linguistic record? Right? So one way is that I take a microphone and I follow a person for 50 years. Right? And basically, I just record everything that person says. That would be one kind of, this would be the old way of doing it. A different way of doing it is that I go and I collect a complete linguistic record of some of online communities, right? And what I'll show you now is examples of 2 online communities for which we have their complete linguistic record over more than 10 years. So this means that for every kind of post, for every communication that happened inside this community, we have a record of it. And we choose 2 very different domains. So the first one is the domain of online beer reviews, okay? So let me just read, like this is a kind of, I will read you a review and you will see that this is highly technical community. So it goes like this, okay? So clear copper colored brew, medium cream colored head, floral hop nose, caramel malt. Okay, so that's how an expert talks about beer, right? So precise, clear, unemotional, things like that. So this is kind of the first community we look at. The second community we look at is an online discussion forum for women with breast cancer disease, right? And here again, basically, what is happening is that these women that are learning how to talk about their disease, express what's going on, in both in cancer and in beer, people are coming up with new words, they're learning new words, the language is changing over time. So our idea is to look at this linguistic record and try to see how is the language changing as a function of time. So what I'll do, I'll show you results for beer just because kind of it's more fun, but everything also is true for breast cancer as well, okay? So here is a first example of a beer community. So what I'm showing you on this graph, the x-axis is time and the y-axis is the usage of a particular word. So here I'm showing you usage of 2 different conventions. So a beer has a smell, and as an expert reviewer, you need to be able to express how the beer smells. So you can use what was called the aroma convention, when you say aroma, semicolon, and then describe the thing. Or you can use the smell convention, which means you use a capital S, semicolon, and then describe the smell. So these are 2 different ways to talk about the same thing. And what do you see? You see that in 2003, the usage of aroma peaked. And then later on in 2006, 2007, the smell convention took over. And the question is why? So to answer this, let me kind of unpack this mystery maybe a bit more. So here is a graph of the smell versus aroma convention for users who joined in 2003. And there on the right is the same kind of graph, usage as a function of time, for users that joined in 2005. So what do we see is that users who joined in 2003, they keep using their aroma convention. Basically, they don't react to the smell convention. People that join in 2005, they ignore the aroma convention and start using the smell convention. So how could we unpack what's going on? So there are really 2 things that are going on. So one thing that is going on is that individual users are basically evolving over time. And the other thing that's happening is also the community is changing as a function of time. So what I would like to do now is show you an example of an individual change, how basically an individual person changes over time. And then I'll show you something about how community changes over time. And then we'll also look how do these processes interact with each other. So first, how the individual changes over time. So here is one example how users change. For example, this is time versus usage of first-person singular pronouns. This is the review number, so how many posts has a user had. And what you see is that the usage of first-person singular pronouns is decreasing over time, which you can explain that basically people talk less about themselves and they talk more about the beer. Or if you want a different way, you can say that this is a sign of an increased identification of a person with the community. Okay, so here is what happens at the individual level. What happens at the global level? For example, at the global level, fruit words are getting more and more popular. Okay, so what do you see? That back in 2003, fruit words like pineapple, citrus, grapefruit were not used to describe beer, and now they are used more and more. So kind of what's one thing that you can take away from this talk? If you want to be perceived as an expert beer person, you should use citrus, pineapple. How does the beer taste? It has a citrusy flavors in them, right? So that's one thing you can take from here. So this is what happens at the community level. So now what we can think of is think of the following. So think of my x-axis as time and my y-axis is some kind of abstract axis of how community language changes over time. And it just kind of is some abstract trajectory through this space. What we also know is that users' language changes over time. And again, let it be kind of some arbitrary trajectory through this abstract space. So now the question is, how do the two things relate to each other? Kind of, can I measure the distance between the language of the community and the language of the user? And actually, we can do that. We can basically use some techniques from statistical language modeling to be able to understand basically what's the cross correlation between the language of the community and the language of the user. So now that we have that, here is, for example, what happens. So what I'm showing you here is the x-axis is user's lifetime. Okay, so 0 is when the person enters the community, and 100 is when they leave. So kind of when they die from our point of view, right? And the y-axis is the distance from the language of the community at that given time. What you see is that users start using language that is very different from the community, and then they kind of slowly converge closer to the community. So what does this mean? Is that this is what's happening, right? Your language starts away and then slowly approaches that one of the community. Of course, the reason why I'm showing you why I'm not showing you the second part of the graph is because something interesting happens there. So what happens is that before people leave, the distance between the language of the person and the language of the community increases again, right? So one potential explanation would be that the person kind of distances themselves from the community, that maybe they start talking off topic, maybe they get unhappy and kind of they're not using the language of the community anymore, the gap increases and the person leaves. That's one possible hypothesis. Another one is to say that what actually happens is that the person starts adopting and they just remain flat. So basically their language gets stuck in the past and it's the language of the community that is getting away from the user. And now what I will show you next is kind of a computational experiment that is able to separate out these two hypotheses. And the way you can do this is to take person's language and ask, is the language you are using today, is this more like the language that people used in the past, or is this more the language that people will use in the future? So for every kind of post that a person writes, I can say, does this look like the future or does it look like the past? So if I do that, I'm showing you this here. So again, x-axis is user's lifetime from 0 to 100, and y-axis is whether their posts look like how the language of the community will be in the future, or do they look like how it will be in the past. And basically you see that young users are using progressive language, while old users are using old language, which basically means that this second hypothesis is true, right? Is that the way people age is by stopping adapting the new language. So basically their language gets stuck in the past and it's kind of the world or the community that is starting to go away from them, okay? And then when kind of this gap increases enough, the people leave. What is interesting though, is that here we took all the people and just kind of stretched their lifetimes to be between 0 and 100. What's interesting is that every person, no matter how long they stay in the community, they go through the same life cycle. So we can talk about basically about an elastic life cycle, in a sense that people who stay very short, who write very few reviews, they quickly converge and quickly go away. While people, for example, that stay long, their distance to the rest of the community is much smaller, and kind of their language remains agile much longer. So why is this interesting? Is because everyone who leaves the community, they basically leave looking old. So regardless of their physical lifetime, everyone goes through the same kind of life cycle. What we can do now is, for example, we can, based on these things that I showed you, we can, based on the language of the user, we can actually predict when the person is going to leave the community, right? So based on how their language started and how it is evolving as a function of time, for example, just using their first 20 posts, we can quite accurately predict whether somebody is going to be a long-term contributor in the community or whether they're going to leave. So that's kind of the first thing I wanted to show you about. The second thing I wanted to show you about is not just how do you measure human behavior and try to understand it, but how can you go and influence it. So the idea here is to ask, how can we create, let's say, incentives in online and also offline communities to get people behave the way we would like them to behave, or to behave well, if you like. So the first question is, what's the incentive mechanism? And one incentive mechanism we looked at is called badges, right? And kind of people work amazingly hard to earn badges. We were actually not the first to realize this. So the first to realize this, I think, was this gentleman who said, give me enough medals and I'll win you any war, okay? So Napoleon figured this out already, right? So, and if you think about this, right, there are many examples of badges around us kind of every day. So, for example, science is pretty much run on badges, right? Kind of whenever I get a grant, if somebody gets a grant, they get a publication out, that's in some sense a badge. Nobel Prizes are nice, kind of hefty badges, right? Army, of course, has badges. Online social networking sites have badges. Also, like education sites and Wikipedia actually have badges where they try to stimulate people to kind of do more work. So the question is, why are badges interesting? And badges are interesting because they play multiple roles. They can recognize a wide range of different behaviors or different activities, and they can serve both as credentials, but also as incentives for people to try to obtain them. So what is the question? The question is, how do these badges translate into the effects on human behavior? And again, kind of to see these effects, we need quite a lot of data. So what we looked at is a question answering community called Stack Overflow. So this is basically kind of programmer's best friend. Whenever you don't know what to do, you go to Stack Overflow, you type a question, in 5 minutes you receive an answer, and usually a really good one. So the way this works is there's 2 million people, 5 million questions, more than 10 million votes on questions and answers, and the site has badges. So kind of the more questions you answer, the more upvotes you get, the more badges you get. And today people on their resumes would, for example, say, oh, I got 17 gold badges on Stack Overflow and my reputation score is this much. So it's kind of a serious thing. Okay, so now we have a complete trace of how people are asking questions and how they receive feedback and also what badges they receive. So the question is, how should we think about badges and how are they modifying our behavior? So what I'll do next, I'll show you kind of a simple utility-based model of how behavior changes under the presence of badges. The way we will think about this is that we'll think about our, let's say, Stack Overflow example as that there are 2 things you can do on Stack Overflow. You can either go ask a question or you can answer it. Okay, so whenever you do an action on the site, you start as a new user at 0, and then you move either to the right or up. Okay, and then how do we represent badges in this action space? They are simply horizontal or vertical lines, right? So what this is saying, as soon as you do 10 actions of type A1, I will give you this badge. Okay? Now that I have a way to represent badges, now I need to represent human behavior. The way I can think about human behavior is that it's simply kind of a vector in which people walk, right? So, for example, for this person, we will call that they have this preferred behavior where they really like doing action of type A2, but they don't like doing A1 too much, right? They are kind of moving in this A2 direction more. Now, the question is, of course, this person, if they keep doing this thing, it will take them very long before they cross my badge line. So what the person will want to do is they will want to maybe change their behavior to get to the badge sooner. So what we will do is to say that the person is going to change their behavior in order to get to the badge fast, but of course changing behavior hurts. It's like exercising. You don't want to do it too much, right? So this is the same thing will happen here. So what we are assuming is that everyone is born with their preferred behavior, and now the badge, you like it, so you will change your behavior kind of as little as possible while still trying to get to the badge. So this is basically the model. So what are the predictions this model makes? So here's the first prediction it makes. For example, this is time, and here is the probability of taking action A1, A2, or A3. Here at 25, we have a badge that we give if a person makes 25 actions of type A1. So what do you see? We see that very far away, the users don't react to the badge. They are this kind of baseline behavior. As they get close to the badge, they ramp up their action of type 1 and at the expense of actions A3 and A2. Okay? But A1 goes up, then they get the badge, and then they just return to the initial behavior. So that's the prediction, right? So users will steer in the direction of the badge, they will get it, and then basically they just go doing their old thing. So that's the first thing. And the second thing that kind of emerges from this is that you can think of these badges as some kind of magnets, right? So here is a two-dimensional example with two badges. And you can think of these vectors as the direction in which the users are moving, right? So as they get close to the badge, they get more and more attracted to it, they get it, and then they go the other way, and so on. So these are kind of things that the model predicts. So now the question is this happening in real life? So here's an example of a Stack Overflow badge that's called an electorate badge. You get it if you voted on at least 600 questions. So there is a question, and you can say this is a good question or this is a bad question, and you've done this 600 times. So the time 0 is the time when you earn a badge, and this is the number of actions per day of a different type. On Stack Overflow, you can do exactly 4 actions. You can ask a question, you can answer a question, you can vote on a question, or you can vote on an answer. What you see here